Hello and welcome. Today we're going to speak about spinal pathways, specifically about sensitive or ascending pathways. First, we're going to start speaking about the general organization of these fibers. So we've got that there are three neurons in this system, generally. The first one is situated in the dorsal root ganglion, which is here. It introduces itself into the spinal cord where the second neuron is situated. It can actually be situated, as we will see, anywhere within the spinal cord or up to the medulla oblongata. So it's important to say that this first synapse will always occur on the homolateral side to where the fibers are introducing themselves into the spinal cord. So to say on the same side. Then this second neuron will be the one that changes side. There will be a decussation. It will change side and continue ascending up to the thalamus, where it will synapse with the third neurons, which will finally remit themselves to the final destination. Here we can see the cortex. So this is what we're going to speak about today. We've got the posterior columns to begin with, then the anterolateral system, which includes different tracts, and finally the spinocerebellar tracts. The dorsal columns, which continue themselves with the medial lemniscus. Now these are fibers that bring information of epicritic touch, vibration, and conscious proprioception. Like before, we've got the first neuron, which is situated in the dorsal root ganglion. It will then ascend. This time the second neurons are not on the same level. They are situated in the medulla oblongata. So this first neuron will have to ascend. It will have to send its axon to the medulla oblongata. Now as they ascend, they form fasciculi. The more lower fibers, the fibers coming from lower limbs and lower part of the trunk, they form the fasciculus gracilis, whilst the upper fibers coming from upper limbs and upper part of the trunk form cuneatus fasciculus. Now we can see that they finish in the nucleus gracilis, that's the end of the fasciculus gracilis, and nucleus cuneatus at the end of the fasciculus cuneatus. This is where the second neurons are situated, in the medulla oblongata. They will then decuss, they will change side and ascend in the medial lemniscus. They will ascend up to the thalamus, specifically the ventral posterolateral nucleus of the thalamus, and then the fibers will be remitted to the somatosensory cortex. Now in these cuts we can see at a sacral and at a lumbar level, this is the dorsal side here, we have only gracilis fasciculi. Here we have gracilis fasciculus and gracilis fasciculus. Whilst in the cervical and the dorsal or thoracic level, we have also cuneatus fasciculi. Now this is because, as we said before, the fibers that form the cuneatus fasciculus come from the upper part of the trunk and upper limbs, whilst the gracilis fasciculus, it is formed by fibers coming from the lower part of the trunk and lower limbs. So we can only see cuneatus fasciculus from a thoracic level upwards. The anterolateral system, as we said before, is formed by different tracts that are not easily discriminated one from another. First of all, the spinothalamic tract. Spinothalamic tract brings information of protopathic touch, pressure, thermic sensibility, and pain, nociception. It's all somatic information and not visceral information. Now here we have that the first neurons from the dorsal root ganglion introduce themselves again into the spinal cord, but this time the second neurons are located in the spinal cord, not in the brainstem. In the spinal cord at a very similar level from which the fibers of the first neurons introduce themselves into the spinal cord. So actually these axons introducing themselves from the first neurons are very short. These second neurons cross sides again, like before, and ascend to the same nucleus of the thalamus. That's the ventral posterolateral nucleus of the thalamus, and again remit their message to the somatosensory cortex. Now, the spino-reticular-thalamic tract, this can also be called the paleo-spinothalamic tract because it is considered more ancient in its evolution, I suppose. And this tract introduces it's the same as the spinothalamic tract, but it introduces itself into the reticular formation in the brainstem, where it will have one or several synapses, and then continue ascending to the thalamus, and again to the cortex. Except that this time the message, first of all, will be slower, but also more diffuse. It will not be so concrete in special areas of the somatosensory cortex, but it will be all over the cortex in a diffuse manner. So it has a function of an important activator of the cortex. The spinotectal tract ends in the superior colliculus, so at the midbrain level, at mesencephalon level, and it's important for spino-visual reflexes. That is, to orient one's eyes, head and trunk towards a stimulus. The spino-olivary tract ends in the inferior olivar nucleus, where it will have a second decussation. It will again cross sides. And through the pedunculus cerebellaris inferior introduce itself to the cerebellum. So as we said, it has its second decussation, so this means that it will come back to the homolateral side and introduce itself into the homolateral part of the cerebellum. This is important to learn motor conduct. Now, this is all, and we have to speak about spinocerebellar tracts. Mainly, we have three here that we're going to talk about. We've got the ventral spinocerebellar tract. This brings information from Golgi tendon organs. The first neuron introduces itself into the gray matter, into the spinal cord, and it will synapse with the second neuron, which is situated in the dorsal nucleus inside the spinal cord in the gray matter. The second neuron will then cross sides and ascend in the ventral spinocerebellar tract. It will ascend until the superior pedunculus cerebellaris and introduce itself both to the contralateral side of the cerebellum, as we can see here, but then some of these fibers will again decuss. They will cross sides again to the homolateral side and introduce themselves to the homolateral side of the cerebellum. So we've got the ventral spinocerebellar tract sends fibers to both sides of the cerebellum. And finally, we will speak about dorsal and cuneiform spinocerebellar tracts. They both bring information from muscular fuses and Golgi tendon organs. The difference is that the dorsal spinocerebellar tract brings information mainly from lower limbs and lower part of the trunk, whilst cuneiform spinocerebellar tract brings information from upper limbs and upper part of the trunk. So the dorsal spinocerebellar tract ends its neurons, the first neurons, synapse with the second neurons in the dorsal root ganglion. These don't cross sides, there isn't a decussation, but they ascend on the homolateral side in the dorsal spinocerebellar tract, which is this green line here. They will ascend and introduce themselves via the inferior pedunculus cerebellaris. Then the accessory cuneiform nucleus. That's in the medulla oblongata. That's where the first neurons of the cuneiform spinocerebellar tract ascend. They ascend straight through the spinal cord up to the medulla oblongata and to the accessory cuneiform nucleus, where the second neurons are situated, and also send their fibers to the homolateral side of the cerebellum via the pedunculus cerebellaris inferior. So we've got the dorsal and cuneiform fibers introduce themselves into the cerebellum via the inferior pedunculus cerebellaris, whilst the ventral spinocerebellar tract fibers introduce themselves through the superior pedunculus cerebellaris. That's all. I hope it was useful, and see you again.